Basic Data Analysis, Descriptive Statistics, Chapter 20, Business Research Methods. So after we're gonna study this chapter, we should be able to know what descriptive statistics are and why they are used, create and interpret simple tabulation tables, understand how cross-tabulation can reveal relationships, perform basic data transformations, list different computer software products designed for descriptive statistical analysis, and understand a researcher's role in interpreting the data. Now the opening vignette is about choosing your drink, and most Americans enjoy an adult beverage occasionally, but not all Americans like the same drink. So many decision makers are interested in what Americans like to drink. So retailers need to have the correct product mix for their particular customer to increase profits and customer satisfaction. So during the 90s, one study from 92 showed a heavy preference towards beer. In 2005, another study, this preference shifted to wine. Another study later on in 2008 showed again a shift to beer. So what should the grocer emphasize in marketing adult beverages? So based on research on counting can address these issues and can address these decisions. So perhaps the most basic statistical analysis is descriptive analysis, and descriptive statistics can summarize responses from large number of respondents in a few simple statistics. When a sample is obtained, the sample descriptive statistics are used to make inferences about characteristics of the entire population of interest. And in this chapter, we're going to discuss about basic descriptive statistics, very simple and very powerful. The nature of descriptive statistics. Descriptive analysis is the elementary transformation of data in a way that describes the basic characteristics such as central tendency, distribution, and variability. For example, consider business researchers who take responses from 1,000 consumers and tabulate their favorite soft drink brand and the price they expect to pay for a six-pack of their product. The mean, median, and the mode for a favorite soft drink and the average prices across all the 1,000 consumers would be descriptive statistics that describe the central tendency in three different ways: mean, median, mode. Variance, range, and standard deviation are widely applied descriptive statistics as well. And in this graph, actually, sample consumers were asked where they most often purchase their beer, and the result is a nominal variable that can be described with the frequency distribution. And what we can see in the top part of exhibit 20.1. The bottom part displayed the example descriptive statistic for interval and ratio variables, and in this case the chart displays results of a question asking respondents how much they typically spend on a bottle of wine purchased in a store. And the mean and the standard deviation are displayed in this chart as well. The frequency distribution is shown with a histogram. Histogram is a graphical way of showing a frequency distribution in which the height of a bar corresponds to the frequency of a category. Histograms are useful for any type of data, but with continuous variable, interval, or ratio, the histogram is useful for providing a quick assessment of the distribution of data. A normal distribution line is superimposed over the histogram, providing an easy comparison to see if the data are skewed or multimodal. Exactly what we see at the bottom part of this exhibit. Tabulation. Tabulation refers to orderly arrangement of data in a table or other summary format. When this tabulation process is done by hand, the term tallying is used, and counting different ways respondents answer the questions and arranging them in a simple tabular form yield a frequency table. the actual number of responses to each category is a variable frequency distribution. A simple tabulation of this type is sometimes called a marginal tabulation. Simple tabulation tells the researcher how frequently each response occurs. So the starting point for analysis requires the researcher to count responses or observations for each category or code assigned to a variable. And then the frequency column shows the tally result, or the number of respondents listing each store, for example, for what they buy. And the percent column shows the total percentage in each category. Cross-tabulation. A frequency distribution or tabulation can address many research questions. As long as a question deals with only one categorical variable, tabulation is probably the best approach. Although frequency counts, percentage distribution, and average summarize considerable information, simple tabulation may not yield the full value of the research. So cross-tabulation is the appropriate technique for addressing research questions involving relationship among multiple less than interval variable. We can think of cross-tabulation as a combined frequency table. Cross-tabulations allow the inspection and comparison of differences among groups based on nominal and ordinal categories. One key on interpreting a cross-tabulation table is comparing the observed table values with hypothetical values that would result from a pure chance. Contingency table. A contingency table is a data matrix that displays the frequency of some combination of possible responses to multiple variables. Two-way contingency tables, meaning they involve two less than interval variables, are used more often. A three-way contingency tables involves three less than interval variables. Beyond three variables, contingency tables becomes difficult to analyze and to explain. Marginals are row and column totals in a contingency table which are shown in its margins, like the name is saying, marginals. Percentage cross-tabulations. When data from a survey are cross-tabulated, percentage help the researcher understand the nature of the relationship by making relative comparisons simple. The total number of respondents or observations may be used as a statistical base for computing the percentage in each cell. And when the objective of the research is to identify the relationship between answers to two questions or two variables, one of the questions is commonly chosen to be the source of the base for determining the percentages. Elaboration and refinement. According to a dictionary, a dictionary defines analysis as the resolution of anything complex into its simplest element. And once a researcher has determined and examined the basic relationship between two variables, he or she may wish to investigate this relationship under a variety of different conditions. And usually a third variable is introduced into the analysis to elaborate and refine the research understanding by specifying the conditions under which the relationship between the first two variables is strongest and weakest. In other words, a more elaborate analysis will ask, will interpretation of the relationship be modified if other variables are simultaneously considered? And then we have elaboration analysis. Involves the basic cross-tabulation within various subgroups of the sample. And the researcher breaks down the analysis for each level of another variable. And the next one is moderator variable. The combination and the interaction between different variables are the result of one variable being used as a moderating variable. A moderator variable is a third variable that changes the nature of the relationship between the original independent and the dependent variable. An example here are our four-legged family members. We have all different size families, but what is often the case in American household is that at least one member of a family is a pet, and overwhelmingly that pet is a dog, a cat, or both of them. But the question is, what does it mean to be a member of the family? And do men or women treat their four-legged friend as family member in different ways? So this would suggest a set of contingent arguments. Thus, treating a pet as a member of the family depends upon whether you are a male or a female. Depends. This poll that was conducted over 2,000 adults across US and all kinds of information related to age, race, gender, as well income and political parties identification as well. It would appear that women are more likely to see their pet as a part of a family, but as well, if you see your pet as a family member, are there different things pet owners do for their pet by gender? And when examining the contingency table for this type of questions, male and females responded frequently or occasionally. So the results are fairly similar, but some interesting results do appear. That females are more likely to have their pet sleep in the bed and buy them a holiday present, and males appear more likely to buy a birthday present, cook something special for them, or take them to work. So the results suggest that the way we treat our pet as a family member depends upon whether we are males or females. How many cross-tabulations? Surveys may ask dozens of questions and hundreds of categorical variables can be stored in a data warehouse. Using computer programs, business researchers could find a relationship by cross-tabulating every categorical variable with every other categorical variable. So it's possible, every possible response become a possible explanatory variable. And researchers addressing an exploratory research question may find some benefit in this type of expeditions. So software exists that can automatically search through volumes of cross-tabulations. And they may even provide some insights into the business questions under investigation. As well, the program may flag the cross-tabulation suggesting the strongest relationship. However, outside exploratory research, researchers should conduct cross-tabulation that address specific research questions or hypotheses. And when hypotheses involve relationship among two categorical variables, cross-tabulations are the right tool for this job. Quadrant analysis is a variation of cross-tabulation in which responses to two rating scales questions are plotted in four quadrants of a two-dimensional table. And the common quadrant analysis in business research portrays or plot the relationship between averages and average responses about the product attributes important and average rating of a company or the brand's performance on that product feature. So the term importance performance analysis is sometimes used because consumer rate perceive importance of several attributes and rate how well the company's brand performs on that attribute. And generally speaking, the business would like to end up in the quadrant indicated high performance or an important attribute. This example here illustrates a quadrant analysis for an international mid-price hotel chain, and the chart shows the importance of the performance rating provided by business travelers. After plotting the scores for each of these 8 attributes, the analysis suggests areas for improvement. The arrows indicate attributes that the hotel company should concentrate on to move from quadrant 3, which means the performance on those attributes is low, but business consumers rate those attributes as important, to the quadrant 4, where attributes are both important and rated highly for performance. Next is about data transformation. Data transformation, as well called data conversion, is the process of changing the data from their original form to a format suitable for performing a data analysis that will achieve research objectives. Researchers often modify the values of scalar data or create new variables. For example, many researchers believe that less response bias will result if interviewers ask respondents for their year of birth rather than their age. So this presents no problem for the research analyst because a simple data transformation is possible. But the raw data coded as a birth year can easily be transformed to age by subtracting the birth year from the current year. Here, collapsing or combining adjacent categories of variable is a common form of data transformation used to reduce the number of categories. And in this example, we have a B-model distributions, and indicates that it's a Likert scale, strongly disagree or strongly agree, and then the variable closely resemble a categorical variable. In general, students either strongly disagree or agree with some statements. So in this case, the researcher may wish to collapse the responses into two categories. And with multiple ways exist to accomplish this, the researcher may assign the value of 1 to all respondents who either strongly disagreed or agreed with the value 2 of all the respondents who either agreed or strongly agreed. So respondents marking neutral would be deleted from this analysis in this histogram case. Problems with data transformation. Researchers often perform a median split to collapse a scale with multiple response points into two categories. The median split means respondents below the observed median go into one category and respondents above the median go into another. Although this is common, the approach is best applied only when data do indeed exhibit B-model characteristics. When data are unimodal, such as would be the case with normal distributed data, median split will throw away valuable information and lead to errors. In this example, clearly most respondents either slightly agree or slightly disagree with the statement, and the central tendency could be represented by the median of 3.5, a mean of 3.5, and the modes of 3 and 4. 3 and 4 each have the same number of respondents. So the outlier, if any, appear to be those not indicating something other than a slight agreement or a disagreement. And the case can be made that the respondents indicated slight disagreement are more similar to those indicated slight agreement than they are those respondents indicating strong disagreement. But we can see that the recode places value 1 and 3 in the same new categories, but placing values 3 and 4 in a different categories. And then the data distribution does not support a median split into two categories, and so a transformation collapsing the values into agreement and disagreement is inappropriate. Index numbers. The Consumer Price Index and Wholesale Price Index are secondary data sources that are frequently used by business researchers. Price indexes, like other index numbers, represent simple data transformation that allow researchers to track a variable value over time and compare a variable with other variables. Recalibration allows scores or observation to be related to a certain base period or a base number. Rank order. Survey responses are often asked to rank order their preferences from some items, issue, or characteristics. Consumer may be asked to rank their 3 favorite brands, or employee respondents may provide a ranking of several different employee benefits plans. Ranking data can be summarized by performing data transformation. The transformation involves multiplying the frequency by the ranking score for each choice to result in a new scale. This example is about Twitter. And Twitter, you know, it's one of the fastest growing social network, a privately funded organization in San Francisco. But the first prototype we had developed in 2006, and Twitter has evolved, and real-time messages and service compatible with several different networks and multiple services. But if you're familiar, you know that the basic understanding of terminology. After signing up with a Twitter account, you can tweet up to 140 character messages. And followers are people who have signed up or received someone's Twitter message. A retweet occurs when a follower takes a tweet and then tweets that message to everyone in their own network. So encouraging other Twitter users to retweet your message is the key in spreading your message around, you know, across the Twitter sphere. So the index is intended to provide a score, a ranking of Twitter users based on the power of their tweets. Yeah, so this is the index that was developed and is used to assess the most influential Twitter users, numbers of followers, and other reports the number of retweets as well, and then they combine it, and the index is retweets per day divided by tweets per days, and all these ones divided by the followers. Yeah, you see the formula here. This is about Twitter. Tabular and graphic methods of displaying data. Tables, graphs, charts may simplify and clarify data. Graphical representation of data may take a number of forms, ranging from a computer printout to an elaborate pictograph. Tables, graphs, and charts, however, all facilitate the summarization and communication. A researcher may have convenient tool to quickly produce charts, graphs, and table, and even common programs like such Excel and Word include chart function that can construct the chart within the text document. Bar charts, histogram, pie charts, curve line, diagrams, scatter plots are among the most widely used tools. And some choices match well with certain types of data analysis. Bar charts and pie charts are very effective in communicating frequency tabulation and simple cross tabulation. What we see here, the frequency of data from the opening chapter, and each pie summarize preferences in the respective year, 92, 2005, 2008. The size of each pie slice corresponds to a frequency value associated with that choice. When the three pie charts are compared, the result communicated a cross tabulation, and the comparison clearly communicates that wine preferences increased at the expenses of beer preferences from 92 to 2005, but has yielded some ground in 2008. Computer programs for analysis. For just, 50, 60 years ago, the thought of a typical company performing even basic statistical analysis like cross-tabulation on 1,000 or more observations was unrealistic. But the personal computer brought this capability not just to average companies, but as well to small companies and even individuals with limited resources. And today the computing power is very rarely a barrier to complete a research project. When the PC was still in their infancy, still a novel innovation, specialized statistical software used on mainframe computer made the way to the personal computing market. But today, most spreadsheet packages can perform a wide variety of basic statistical options. Excel, probably you know, Excel basic data analysis tool will allow descriptive statistics including frequency and measure the central tendency to be easily computed. Most of the basic statistical features are now menu driven, reducing the need to memorize function labels, and spreadsheet packages like Excel continue to evolve and become more viable for performing many basic statistic analysis. Despite the advances in spreadsheet application, commercial statistical software packages remain extremely popular among researchers, and they are become easier and easier to use and more compatible with other data interface tools, including spreadsheet and word processors. Like any specialized tool, statistical packages are more tailored to the type of analysis performed by statistical analysis, including business researchers. So serious businesses or social science researchers should still become familiar with at least one general computer software package. Two of the most popular ones are SAS and SPSS. SAS was founded in 1976 and is a statistical software historically widely used in engineering and other technical fields. And SPSS is commonly used by universities and social science students and business students as well. Business researchers have traditionally used SPSS more than any other statistical tool. It's seen like a more user-friendly. Excel, SAS, SPSS accounts for most of the statistical analysis conducted in business research. At university, students may as well be exposed to Minitab. This one is preferred by economists. Minitab is viewed as being less user-friendly than other choices. The entry in the past, data entry was an issue as specific software requires different types of data input. But today, however, all these major software packages can work from data entered into a spreadsheet. As well, there is another one, R Statistic. That one is an open source that as well some are using. Now, computer graphics and computer mapping. Graphic aid prepared by computers have replaced graphic presentations aid drawn by artists, and computer graphics are extremely useful for descriptive analysis. Decision support systems can generate 2- or 3-dimensional computer maps to portray data about sales, demographic, lifestyle, retail store, and other features. Computer graphics have become more common as common applications have introduced an easy way of generating 3D graphics and maps. Many computer programs can draw box and whisker plots, which provides graphic representation of central tendency, percentiles, variabilities, and shapes of frequency distribution. A measure of variability called the interquartile range, but the term is misspread and is less complex and more descriptive. The location of the line within the box indicates a median. The dashes that extend from the top to the bottom of this box are the whiskers, and each whiskers extends to either the length of the box or to the most extreme observation in that specific direction. Outliers. An outlier is a value that lies outside the normal range of data. Box and whisker plots are particularly useful for spotting outliers or comparing group categories. Here is a whisker and plot example, and we can see the outliers, the value that lies outside the normal range of the data. Can be potential outliers. Yes, you can see them here. Interpretations. A distinction can be made between analysis and interpretation. Interpretation is drawing inferences from the analysis results. Inferences drawn from interpretation lead to managerial implication. So each statistical analysis produces results that are interpreted with respect to insight into a particular decision. The logical interpretation of the data and statistical analysis is closely intertwined. When a researcher calculates a cross tabulation of employee number of dependents with choice of a health plan, an interpretation is drawn suggesting that employees with a different number of dependents may be more or less likely to choose a given health plan. So this interpretation of the statistical analysis may lead to a realization that certain health plans are better suited for different family situations. From a management perspective, however, the qualitative meaning of data and their managerial implication are an important aspect of the interpretation. So this was about basic data analysis, descriptive statistic, chapter 20. Thank you so much.